10, 9, ignition sequence.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
One small step for man, one giant leap for mankind.
1, 0, and liftoff.
Mission complete, Houston. After serving the world for over 30 years, the space shuttle's earned its place in history and it's come to a final stop.
Von 0 auf Schallgeschwindigkeit in 30 Sekunden als menschliche Kanonenkugel. Kein Kampfjet schafft das, was Extremsportler Felix Baumgartner im freien Fall auf 36 Kilometern über der Erde vorhat. Und eigentlich sollte er schon längst zu seinem Weltraum-Fallschirmsprung Richtung Stratosphäre schweben. Doch eine unerfreulich frische Brise macht ihm bislang einen Strich durch die Rechnung. Christoph Kuhn.
Warten auf den großen Sprung. Diese Menschen aus Roswell haben sich um 5 Uhr morgens den Wecker gestellt. Sie wollen sehen, wie Felix Baumgartner mit 1100 Kilometern pro Stunde Richtung Erde fliegt. Aber der Wind verhindert bisher die Party. Das ist ein historischer Tag für Roswell. Meine Jungs und ich sind extra früh aufgestanden, aber jetzt sehen wir nichts. Das ist echt schade. 19 Uhr deutscher Zeit ist der letzte Starttermin für heute. Sonst wird der Sprung auf einen anderen Tag verschoben. Baumgartner selbst kann es nicht abwarten, endlich loszulegen. Hier noch seine letzten Grüße an die Facebook-Fans. Ich hoffe, wir schaffen es auf 120.000 Fuß. Ich weiß, ihr drückt mir alle die Daumen. Das bedeutet eine Menge für mich. Nach dem Absprung in 36 Kilometern Höhe wird der 43-Jährige 5 Minuten lang im freien Fall auf die Erde zurasen und dabei auch die Schallmauer durchbrechen. Eine extrem gefährliche Situation.
Gerade die Körperteile, auf die sehr, sehr wichtig ist, die durch die Druckwelle dann entsprechend verlagert werden können, insbesondere hier der Kopf mit dem schweren Helm, das könnte natürlich zu sehr unangenehmen Beschleunigungen führen. Bis hin eben, dass auch dabei einem das vielleicht erst Genick brechen kann.
Ein Testsprung aus 29 Kilometern Höhe im Juli glückte. Sollte jetzt auch Baumgartners Rekordsprung gut verlaufen, hat er angekündigt, dass der aus dem Weltall sein letzter gewesen sein soll.
And what you're looking at there is basically the ground crew getting the balloon. Unrolling the balloon that is there. That is the balloon that, if you measure it out, it measures about 40 acres if you were to spread it out completely. And that is the capsule that it will take, that human. His name is Felix Baumgartner, and he will go in there and ascend to 120,000 feet. Now, the special suit that he's wearing will allow him, they hope, to return back to Earth wearing nothing but that suit. He will fly at speeds that will become supersonic as he re-enters the atmosphere. It will take him about 2.5 to 3 hours to actually get up to 120,000 feet, but that fall back to Earth will take about 15 to 20 minutes. And then his parachutes will deploy, and hopefully he will land safely back somewhere in New Mexico, they hope, where they can go and retrieve him. So hopefully that'll all work out as planned. I want to show you one more thing, the little game people are playing online. I don't know if you like to play online games, but you can estimate where Felix will land. And you can see right over here everywhere that people have actually tried to guess where that will happen. The blue that you see right there is where the launch site actually is. So pretty cool stuff. And, you know, we'll have to see how it happens. It's expected, the launch expected to happen probably in about an hour's time.
Baumgartner is still hoping to set a skydiving record if he jumps from the edge of space today. There have been delays all the way through the day so far, and we've been kept waiting. But the Austrian is still going to attempt to become the first person to go faster than the speed of sound without an aircraft. From New Mexico, here's the BBC's Palab Ghosh.
Release the seatbelt, release seatbelt.
Felix Baumgartner in training for his world record jump. He'll be taken 23 miles up by balloon to the edge of space. He's so high up that if his spacesuit leaks, his blood will boil. When he jumps, he'll fall so fast, he'll break the sound barrier. No one knows what effect that'll have on his body. But after his last test jump, he was upbeat.
We practiced this for so many years, and now we're almost there. So this is my biggest dream, and we're one step closer, and I'm almost there, so I feel good at the moment.
This is the Mission Control Center where engineers are making the final preparations for the jump. There's some tension, but a lot of excitement. It's from here that engineers will track Felix's vital signs and follow Felix's progress from the moment he steps off the capsule as he falls to Earth. The launch will be at a small airfield in Roswell, New Mexico. The balloon is 55 stories high and thinner than a plastic bag. Felix will get in the capsule, and once the wind drops, the crane releases it, and away he'll go. Felix's mother and other family members and friends have come to wish Felix luck and watch with pride as he falls further and faster than anyone has fallen before. Palad Ghosh, BBC News, Roswell in New Mexico.
Well, the mission will launch, as we heard, in New Mexico. Our science correspondent Jonathan Amos is there. Jonathan, just bring us up to date on if and when this is going to actually happen today.
Well, it looks as though we may get off. We've got our fingers crossed here. They've laid this enormous balloon, 850,000 cubic meters is the capacity. They've laid it out on the runway. They have the capsule at the end, and they've begun to inflate the balloon. And that's quite important because this is a use it or chuck it balloon. You can't roll it away and come back another day. Once you rolled it out, you're committed to doing something with it, even if it's just throwing it away. So we'll see shortly Felix Baumgartner come out in his pressure suit and start to pre-breathe oxygen. He needs that to get the nitrogen out of his bloodstream so that when he's high up in the atmosphere, he doesn't get any problems from degassing. So we could be perhaps an hour away from liftoff.
Wow. And once he lifts off, Jonathan, how long will it take him to get to that incredible height, 30,000 meters or so above the ground?
Probably around about 2.5, 2 3/4 hours, I should think. It'll depend very much on how the atmosphere is playing up there. It takes quite a while to get up. It takes no time to come back down. It'll take him about 10 minutes. He'll free fall all the way down to about 1.5 kilometers above the ground, and then he'll open his chute and he'll negotiate that last little passage to the ground, probably about 50 to 60 kilometers away from here. There are cameras dotted around the countryside with big telephoto lens to capture the fall, so we should be able to see him all the way down.
We can only imagine what must be going through his mind, Jonathan. And just tell us, other than the incredible feat of skydiving from this height, what is this actually proving, this experiment, this incredible venture?
We're on a cusp of introducing new types of space vehicles, tourist vehicles, but also vehicles for the big space agencies as well. And there's been a lot of talk about whether you could evacuate one of those vehicles in an emergency. We saw with the Columbia shuttle accident that obviously that didn't happen, it couldn't happen, but some of the research in this project will feed into future ideas about that. It'll also test new parachute systems and also pressure suit systems as well. He's wearing an evolution version of the famous orange suits that the shuttle astronauts used to wear. So down the line, there's a lot of people looking at this data, hoping they can draw from it.
Jonathan, thank you for now. Jonathan Amos there in New Mexico as we expect that mission to possibly get underway over the next few minutes in the course of the next hour, and that balloon now being inflated. As Jonathan says, it's a one-use only balloon, so they wouldn't want to start inflating it if they weren't going to go ahead. So signs are positive. We'll keep you up to date, of course, as soon as things start moving.
Todesmutiger Sprung. In wenigen Minuten steigt der Extremsportler Felix Baumgartner mit seinem Heliumballon auf, um sich dann vom Rande des Weltalls in die Tiefe zu stürzen. Es ist ein nervenaufreibender Tag heute für Felix Baumgartner in Roswell im US-Bundesstaat New Mexico. Die Welt wartet auf den Rekordsprung des Extremsportlers aus 36 Kilometern Höhe. Aber wegen gefährlicher Winde musste der Start ins Abenteuer heute Nachmittag mehrfach verschoben werden. In diesen Minuten wird es aber ernst. Der Countdown läuft. Der Heliumballon, der den Österreicher Richtung Weltall bringen soll, ist bereits gefüllt. Baumgartner hat schon seinen Spezialanzug an und atmet nur noch reinen Sauerstoff. Burkhard Wennemer und Christina Enrostadt berichten.
5 Jahre hat Felix Baumgartner auf diesen Moment gewartet. Der Ballon wird ausgerollt, die Kapsel ist fast startklar. Bereits gestern hatte sich der 43-Jährige von seinen Fans per Facebook verabschiedet.
Dies ist das letzte Mal, dass ich zu euch sprechen kann, weil ich in einer Stunde ins Bett gehen werde.
Um 2 Uhr früh stehe ich schon wieder auf, muss dann die letzten Medizinchecks machen und bekomme Infos zum Wetter. Dann geht es zu der Kapsel. Ich weiß, dass ihr mir alle die Daumen drückt, tut das auch weiter, das ist sehr wichtig für mich. Selbst Felix' Mutter durfte ihren Sohn heute nicht mehr sehen, sie war am Nachmittag aber guter Dinge.
Im Moment geht es mir sehr gut, muss ich sagen. In der Früh war ich sehr aufgeregt, jetzt hat sich das ein bisschen stabilisiert, so wie der Wind auch.
Doch das Abenteuer ihres Sohnes ist ebenso gefährlich wie spektakulär. Schon der Absprung birgt ein großes Risiko. Denn wenn er nicht richtig abspringt, kann ein sogenannter Flachtrudeln geraten. Dabei wird ihm das Blut in den Kopf schießen, durch den Druck platzen ihm die Augen, das kann niemand überleben. Ein weiteres Risiko, wenn sein Anzug einen Riss hat, kann sein Blut anfangen zu kochen. Denn der Siedepunkt liegt in dieser Höhe weit unterhalb der Körpertemperatur. Nach 30 Sekunden soll er dann so schnell sein, dass er die Schallmauer durchbricht. Das nächste lebensgefährliche Risiko.
Ehrlich gesagt, keiner weiß es genau, was dabei passiert. Es hat noch keiner probiert. Aber was man denken könnte, ist, dass er, wenn er mit dem Kopf zum Beispiel die Schallgeschwindigkeit schon erreicht hat, mit den Füßen aber noch nicht, die Schallwellen kollidieren und letztendlich kann das zum Genickbruch führen.
Wenn alles gut geht, wird er rund 15 Minuten nach dem Absprung irgendwo in der Wüste von New Mexico landen, wie hier bei einem Testsprung. Am Anzug trägt er einen GPS-Sender. Sobald er lokalisiert ist, holt ihn ein Helikopter zurück zur Stratusbasis nach Roswell.
Tja, und auf dem Flugfeld von Roswell beobachtet unsere USA-Korrespondentin Christina Endruschat die Startvorbereitung. Geht das Abenteuer jetzt wirklich los oder kann doch noch was dazwischen kommen, Christina?
Es sieht im Moment auf jeden Fall ganz gut aus, denn genau hinter mir auf dem Flughafengelände ist der Ballon ausgebreitet worden. Ein sehr gutes Zeichen, denn wenn er einmal aus der Verpackung genommen wurde, dann kann man ihn sowieso nicht mehr verwerten. Die Startkapsel ist auch schon in Stellung gebracht mit Felix Baumgartner und eigentlich gerade jetzt beginnt der Ballon schon mit Helium gefüllt zu werden, bis er eine Größe erreicht von 55 Stockwerken. Das wird jetzt circa 1 Stunde dauern. Also ich rechne mit einem Launch circa um 20 Uhr. Und dann dauert es nochmal 2,5 bis 3 Stunden, bis Felix Baumgartner dann seine gewünschte Position von knapp 37 Kilometern erreicht hat. Und sein Expertenteam hat uns schon verraten, bevor er springt, wird er einen letzten Satz sagen. Was genau, das bleibt aber bis dahin sein Geheimnis.
Okay, wir werden es hoffentlich erfahren. Drücken wir ihm die Daumen. Ganz herzlichen Dank, Christina Endruschat, für diese Informationen aus New Mexico.
Es war ein meteorologischer Grund am Ende, der zum Abbruch der Mission geführt hat. War das aus Ihrer Sicht die richtige Entscheidung? Sie haben die Bilder ja auch mit uns hier gesehen, wie der Ballon sich blähte und zur Seite kippte und beinahe schon den Boden berührte.
Ja, definitiv. Also zum einen die Böigkeit des Windes ist natürlich dann in solchen Momenten ein Problem. Und das nächste Problem ist, und das hatten wir ja auch schon mehrfach gehört, haben auch vorhin schon darüber gesprochen, ist die Vorhersagbarkeit von solchen kleinräumigen und kurzfristigen Ereignissen. Und es muss eben eigentlich eine absolute Windstille herrschen. Und dementsprechend war das eigentlich wirklich nicht die richtige Witterungslage. Man hat ein bisschen auf das Glück gehofft, ist leider ausgeblieben. Vorhersagbar in dieser Art und Weise ist eigentlich sehr schwierig. Wie gesagt, heute Mittag hatte ich auch schon gesagt, ich bin da eher pessimistisch. Hat leider auch nicht geklappt. Vielleicht wird es ja am Donnerstag noch was. Ansonsten muss man natürlich wirklich sagen, wir bewegen uns auf den Winter zu und damit wird das von den Strömungs- und Witterungsverhältnissen dann insgesamt doch auf jeden Fall ja auch eher eine unglückliche Sache. Der ursprüngliche Starttermin im Juli wäre, was das Wetter angeht, sicherlich der bessere gewesen.
Deutschland steht Griechenland im Kampf gegen die Euro-Schuldenkrise weiter zur Seite. Das versicherte Bundeskanzlerin Merkel heute dem griechischen Ministerpräsidenten Samaras in Athen. Beide setzen darauf, dass Griechenland Mitglied der Eurozone bleibt. Das Land hat nach einem Ultimatum der Eurogruppe bis zum 18. Oktober Zeit, die Sparauflagen umzusetzen. Der erste Besuch Merkels in Griechenland seit Krisenbeginn wurde von heftigen Protesten begleitet.
Mit der demonstrativ gezeigten Harmonie hat Bundeskanzlerin Angela Merkel ihrem Gastgeber Antonis Samaras politischen Rückenwind und Anerkennung geben wollen. Man sei Freund und Partner, so die Kanzlerin, und wolle ein neues Kapitel der Zusammenarbeit aufschlagen. Gewaltexzesse, Tränengas und zahlreiche Festnahmen, nur wenige Straßen weiter, das waren die anderen Begleiter des Besuchs. Autonome und Anarchisten lieferten sich bis in die Abendstunden heftige Kämpfe mit Spezialkräften der Polizei. Doch der Großteil der 50.000 Demonstranten, mobilisiert von Gewerkschaften und den Oppositionsparteien, protestierte friedlich. Hier wurde mit Schmähungen und Nazi-Vergleichen Stimmung gemacht für das Ende von Sparprogrammen und Lohnkürzungen. Die breite Masse der Griechen war jedoch zu Hause geblieben. Auf der Pressekonferenz am Nachmittag betonte der griechische Regierungschef die Bereitschaft zu weiteren Reformen. Das griechische Volk blutet in diesem Moment, so Antonis Samaras. Aber es ist entschlossen, im Euroraum zu bleiben und es verlangt nicht mehr Geld, keine Gefälligkeiten. Es verlangt allein die Möglichkeit, sich auf die eigenen Beine zu stellen. Und das so schnell wie möglich.
Ich wünsche mir, dass Griechenland in der Eurozone bleibt. Die Voraussetzungen, die wir jetzt zu erfüllen haben als nächsten Schritt, ist der Troika-Bericht. Alles, was für diesen Troika-Bericht notwendig ist, haben wir heute besprochen. Vieles ist geschafft, manches bleibt noch übrig und daran arbeiten wir jetzt mit Nachdruck und in Partnerschaft.
Es war heute in Athen ein Staatsbesuch, der das politische Verhältnis zwischen Deutschland und Griechenland womöglich wieder normalisieren kann.
Zum Besuch von Bundeskanzlerin Merkel und den Protesten in Griechenland. Jetzt live aus Athen, Bernhard Wabnitz.
Einen Sieger gab es heute Abend ganz gewiss in Athen und das war Ministerpräsident Samaras. Vor dem Besuch von Bundeskanzlerin Angela Merkel aus Deutschland hatte seine Regierungskoalition noch gehörig gewackelt. Nun wird er Auftrieb haben, denn er hat zwei Zusagen. Die erste heißt, Griechenland soll im Euroraum bleiben und die zweite Zusage heißt, Deutschland wird diesen Weg begleiten. Als kleines Trostpflaster brachte Angela Merkel schon mal 30 Millionen Euro mit zum Aufbau des Gesundheitswesens und der Verwaltung. Doch auf der Straße die Protester, sie glauben noch nicht so richtig dran, dass die Regierung und die Bundeskanzlerin das Problem lösen würden und vor allen Dingen, dass sie ihnen langfristig helfen. Zu lange und zu intensiv waren die Einschnitte, die man den Griechen zugemutet hat. Und dann gab es noch anderen Besuch aus Deutschland. In Griechenland wird heute Abend eine Rosa-Luxemburg-Stiftung eröffnet unter Begleitung von einigen Politikern der Linken. Insofern zeigt sich das ganze politische Spektrum Deutschlands in Griechenland. Und damit zurück zu Marc Bartor.
In Frankreich hat der Europäische Fiskalpakt für mehr Haushaltsdisziplin die erste parlamentarische Hürde genommen. Die Nationalversammlung votierte trotz vereinzelten Widerstands in den Reihen der regierenden Sozialisten mit großer Mehrheit für den Vertrag zur Einführung nationaler Schuldenbremsen. Nun muss noch der Senat zustimmen. In den großen Städten gingen heute Tausende gegen Sparpläne auf die Straße.
Ein passender Ort zum Demonstrieren für die Arbeiter von Peugeot, Citroën und anderen aus der Autoindustrie. Der Automobilsalon in Paris. Drinnen Edelkarossen, draußen wütende Arbeiter. Ihr Ziel: in den Hallen demonstrieren gegen den massiven Stellenabbau. 8000 immerhin sollen allein bei Peugeot und Citroën wegfallen. Die Polizei war vorbereitet und drängte die Demonstranten mehrfach mit Tränengas zurück. Die anschließende Demonstration in Paris und anderen französischen Städten verlief friedlich. In ganz Frankreich konnte die kommunistische CGT 90.000 Menschen nach ihren Angaben mobilisieren. Für Arbeitsplätze und gegen Sparpläne. 3 Millionen Arbeitslose. Mit dieser Rekordzahl war die Abstimmung über den Fiskalpakt und über eine strikte Haushaltsdisziplin im französischen Parlament mit Spannung erwartet worden. Dem Vertrag mit einer automatischen Schuldenbremse wurde heute mit absoluter Mehrheit zugestimmt. Eine Mehrheit der Linken mit wie erwartet 20 Abweichlern aus den eigenen Reihen. Diese große Mehrheit zeigt, dass die Linke sich hinter den europäischen Fiskalpakt vereint hat. Ein Pakt, der Stabilität, Disziplin, aber auch Wachstum ermöglicht. Die Stimmen der oppositionellen UMP brauchte die sozialistische Regierung nicht. Test bestanden, aufatmen also für François Hollande. Gestärkt ist seine Position in der Bevölkerung damit natürlich nicht. Nach neuesten Umfragen sind nur noch knapp über 40% der Franzosen mit seiner Regierungsführung zufrieden.
Der Nobelpreis für Physik geht in diesem Jahr nach Frankreich und in die USA. Die Königlich Schwedische Akademie der Wissenschaften in Stockholm zeichnete Serge Haroche und David Wineland für ihre Arbeiten im Bereich der Quantenphysik aus. Sie hätten bahnbrechende Erkenntnisse über die Wechselwirkung von Licht und Materie geliefert. Diese könnten etwa bei der Entwicklung einer neuen, sehr schnellen Computergeneration helfen.
Daheim in Boulder, Colorado, zeigt sich, ein sichtlich beeindruckter David Wineland. Den Journalisten mit dem Nobelpreis habe er nicht gerechnet in diesem Jahr. Ich habe geschlafen. Der Anruf kam um 3:30 morgens. Meine Frau ist ans Telefon gegangen. Wir sind beide etwas übernächtigt jetzt. Ich freue mich, gemeinsam mit Dave ausgezeichnet zu werden, habe ihn auch direkt angerufen und ihm gratuliert, ergänzt Mitpreisträger Serge Haroche. Haroche forscht in Paris am Collège de France und an der École Normale Supérieure. Den Preisträgern sei gelungen, winzige Energiebündel, die sogenannten Quanten, einzufangen und zu manipulieren, so das Nobelkomitee. Bis dato waren Quanten immer zerstört worden, wenn sie wissenschaftlich untersucht wurden. Durch die Erkenntnisse der beiden Physiker können neuartige Atomuhren entwickelt werden, die die Zeit noch genauer messen. Heute funktionieren Atomuhren mit Cäsium. Wenn wir die Forschung der Preisträger nutzen, dann werden wir Präzisionsuhren konstruieren können, die 100-mal genauer sind. Außerdem sei ein wichtiger Fortschritt gemacht worden hin zu revolutionären Quantencomputern. Das werden Computer sein, die schneller sind als alle bisherigen, ein Traum für jeden Programmierer. Am 10. Dezember wird der Nobelpreis für Physik in Stockholm verliehen.
Leipzig erinnert heute mit dem Lichtfest an die friedliche Revolution in der DDR. Die Veranstaltung begann mit dem Friedensgebet in der Nikolaikirche, dem Ausgangspunkt für die Montagsdemonstrationen im Herbst 1989. Heute vor 23 Jahren hatten sich Zehntausende Menschen dem Protest angeschlossen.
Hallo SPD, herzlich willkommen zu meinem Ratgeber Endlich wieder Volkspartei werden in nur 2 Minuten. Es ist kinderleicht. Erstens, lügt mich nie wieder an! Seit Anfang 2011 wusstet ihr Säcke, dass Sigmar Gabriel nicht Kanzlerkandidat wird. Und trotzdem täuscht ihr mir kackdreist eine Troika vor. Sehe ich aus wie ein Idiot? Sehe ich aus wie ein Idiot? Ich hasse es, wenn man mir etwas vortäuscht. Das hat meine Ex-Frau Renate auch immer. Ach. Zweitens, kauft euch mal ein Lexikon. Opposition kommt aus dem Lateinischen oppositio. Entgegensetzen. Kuckuck. Klingelt da was? Ihr müsst der Regierung etwas entgegensetzen. Und nicht wie die Klatschaffen alles abnicken, was die Merkel euch vorsetzt. Holt euch doch gleich ein Autogramm von der Alten. Drittens, versucht es doch einmal mit Charme und Freundlichkeit. Verfluchte Scheiße doch mal, wenn ihr schon Professor Klugscheiß hier, diesen elitären Schnösel, diesen Sockenbügler ins Rennen schickt, dann muss der Rest der Truppe umso sympathischer rüberkommen. Ihr habt doch Leute, die das können. Hier, nein, nicht die. Seid ihr bescheuert? Ich habe gesagt, sympathisch. Nein. Um Gottes Willen. Geht. Der hat eine Fliege. Sag mal, spreche Chinesisch? Volksnah und sympathisch. Weißt du was? Geht kacken. Euch ist nicht zu helfen.
Es darf mal sein, oder?
Also, ich kaufe den ein als Berater.
In Control Houston, this is a live look inside the International Space Station Flight Control Room here in Houston, Texas. We want to welcome you to NASA Television's live coverage of the arrival of the SpaceX Dragon cargo craft to the International Space Station. This room here has already started working. The flight director there is Ron Spencer. He is standing up there in the middle. The CATCOM is veteran astronaut C.J. Sturko. You will hear him talking with the crew of Expedition 33 aboard the International Space Station. This team here has begun operations in earnest with their counterparts in Hawthorne, California at the SpaceX Flight Control Center there. This Dragon spacecraft lifted off from Cape Canaveral, Florida on Sunday evening, October the 7th at 7:35 p.m. Central Time. It has spent 2 days heading up to the International Space Station. Of course, this is playback of the launch on Sunday evening.
7, 6, 5, 4,
A few of the burn times that this Dragon spacecraft will be conducting this morning have been slightly tweaked. That is because of a small issue that happened on board the first stage of the Falcon 9 as it went up into orbit on Sunday night. One engine went out on the Falcon 9, which caused the second stage to burn a bit longer than had been planned. So the teams over the past 24 and 48 hours have fine-tuned these burns, putting Dragon on course for the International Space Station. The spacecraft itself, the Dragon, is in good shape. The SpaceX team has been talking regularly with the team here in Houston, and all the systems are checked out and are ready to support the rendezvous and berthing coming up in about a little bit less than 3.5 hours from now.
Plus 45.
Of course, this is not the first time that Dragon has been to the International Space Station. Back in May, both the Falcon 9 and the Dragon performed a final shakeout flight of both spacecraft as part of NASA's Commercial Orbital Transportation Services program.
AI burn about 15 minutes ahead of schedule.
Copy that. Thanks for the update.
You hear CJ Serco, the Capcom there, confirming to the crew on board the station that what is known as the AI burn, this is the approach initiation burn, was just completed. This is about 15 minutes ahead of schedule. As we mentioned at the top of the broadcast, some of these burns are going to be done a little bit earlier than had been planned. But everything moving according to the timeline in terms of the schedule of events. This approach initiation burn puts Dragon, which you see there is a small dot in the screen, on its final course toward the International Space Station. There will be a series of automatic holds that Dragon will conduct as it gets closer and closer to the International Space Station complex. Once it is about 1,000 meters out, that is when the crew will begin to monitor the progress of the vehicle. Sonny Williams and Aki Hoshide will be the two crew members who will be the primary points of contact for Dragon. They will be inside the cupola, with Aki Hoshide taking the lead on the actual grappling process, with Sonny backing him up. But they will begin to monitor this using both the crew command panel that is there inside the cupola. This allows them to interact with the spacecraft as it gets close. In the event that the Dragon needed to perform an abort, they could issue that command from there.
Monitor 1, you can see a good view of the Dragon.
Awesome, thanks.
The Dragon will continue to close in on the orbiting complex. It will automatically hold at 250 meters. There will be a go, no-go conducted there to make sure that all the systems are ready to proceed. Dragon will then enter into what's known as the keep-out sphere. This is an imaginary circle around the International Space Station that visiting vehicles must stay out of. It will hold once again inside 30 meters. And then once at that point, it will continue on up to about 10 meters or 30 feet, and that is the capture point. Dragon will be performing what we here at NASA refer to as a berthing rather than a docking. They are different. Spacecraft such as the Progress and the Soyuz and formerly the Space Shuttle conducted dockings, which means simply that they went on up to the International Space Station and made physical contact, both piloted and automatically. But items such as the Dragon and also the Japanese HTV and the upcoming orbital Cygnus vehicle all perform a berthing, which means they basically fly very near to the station. They sort of hang out there and hold position, and then the crew uses the station's 58-foot-long robotic arm to reach out and grab onto the vehicles and then bring them on in the final few meters for an attachment point there on the bottom side of the station. The Dragon is going to be bound for the bottom side of the Harmony. No, this is the same spot that it was attached to back in May during that demonstration flight. And once again, Aki Hoshide will be at the controls of the arm. There you see a good sense of the layout of the station. Once Dragon arrives, you see Columbus there on the left. That is actually technically on the right side of the station, because the station flies with the U.S. segment forward. And then the Harmony there in the middle, and then the Japanese Kibo laboratory there on the far left side. You can see Dragon's solar panels there extended. This vehicle is fairly large for our cargo craft. It is 4.4 meters tall, which is about 14.5 feet. It is a little more than 3.5 meters in diameter, which is about 12 feet. The trunk, which is the bottom portion that the solar panels are attached to, is about 9.2 feet tall and 12 feet wide. And as you can see, a good view there of the solar panels. Whenever they're fully extended, the vehicle is 54 feet wide, which is wider than a 5-story building. So it's a fairly sizable vehicle that is currently heading up to the station. And of course, that view you see there is going to get clearer as the vehicle draws nearer to the orbiting complex. We mentioned NASA's COT program at the top of the broadcast. Once again, this is the Commercial Orbital Transportation Services. This is sort of the parent program of this SpaceX Dragon spacecraft. SpaceX joined NASA's COTS program back in 2006. That was the origination of COTS. COTS was a revolutionary way for NASA to invest funds in commercial companies here in the United States to create their own cargo spacecraft and launch vehicles. With the space shuttle retirement drawing closer back in those years, the agency realized that we needed our own way of delivering cargo up to the International Space Station from American companies, since the space shuttle would be no longer available and we could not take up and return our own cargo. So funds were invested in two different companies, once again SpaceX in 2006, and then Orbital Sciences came along in 2008. And since that time, both companies have been working on their launch vehicles, with SpaceX having its Falcon family of rockets. Orbital Sciences has its Antares rocket. And then, of course, this Dragon spacecraft being the actual cargo delivery vehicle that SpaceX created and tested over the past several years. And then Orbital has its Cygnus vehicle. But back in December of last year, SpaceX flew a test flight of the Falcon 9 rocket from Cape Canaveral. It launched a mock-up of Dragon into orbit.
Great news, Sonny. Thanks for letting us know.
And the crew there confirming that they have eyes on Dragon as it closes in on them. After that December test flight, a few months later in May of this past year, SpaceX did launch Falcon 9 and Dragon once again. And Dragon went through a series of checkouts and headed up to the International Space Station. The flight path for Dragon back in May was a little bit different than it will be today, because of the fact that Dragon had to perform a series of checkouts as it headed up to the orbiting complex. On the third day of the flight, Dragon performed what amounts to a flyby of the station. It flew directly underneath while it tested out its abort capability. The crew, which at that time was Don Pettit and Andre Kuipers, took a look at it, make sure that they could communicate with it. And then at the end of that third flight day, Dragon performed a loop of the station, setting up for the next day's events. And then on flight day 4 of that mission back in May, Dragon steadily closed in on the International Space Station. It performed another series of checkouts where it held position and then aborted, and then went up again, drawing ever closer to the space station. And then everything checked out according to plan, and Dragon did end up berthing with the International Space Station, wrapping up SpaceX's participation in NASA's COTS program and setting us up for today's activities, which this is the first time that a U.S. commercial company will fly one of these missions under NASA's Commercial Resupply Services contract that is part of the International Space Station. So quite a milestone happening today for both NASA and SpaceX based there in California. Orbital, which is the other company, is getting ready to fly some test flights as well. They're going to be launching their Antares rocket from the Wallops Flight Facility up on the eastern coast of the U.S. coming up before the end of the year. And then they will do a similar mission to what SpaceX did in May, where they will fly their Cygnus vehicle up to the International Space Station. That should take place in the spring of 2013, paving the way for their resupply missions to the station next year. For those of you who have not taken a look at the SpaceX headquarters there before, it is a little bit unusual in how they're set up there. The Mission Control Center there for SpaceX actually is there on the factory floor. So this Dragon that we're taking a look at was actually born and built there just a few feet away from these flight controllers are sitting. SpaceX has quite an unusual manufacturing process that basically brings metal in one end of the building and spacecraft come out the other end. So these flight controllers have worked there next to the spacecraft that they're watching fly right now. It's sort of a one-stop shop for both mission operations and spacecraft fabrication there at the company, which again is based on Hawthorne, California. But Elon Musk, the founder of the company, sitting there on the far right-hand side of the screen, monitoring his and his fellow employees' spacecraft as it closes in on the orbiting complex.
Houston, station on 2 for Robo. SSRMS and RWS configured for monitoring Dragon approach.
We concur, Aki. Thanks a lot.
And of course, the main purpose of Dragon is to bring up cargo to the International Space Station once completion of the station was achieved last year. And the station entered into its main purpose, which is a world-class research laboratory up in space. Resupply of that orbiting complex became even more important than it was during the actual building of it. All of these experiments that are on board, which there have been close to 1,500 since the creation of the International Space Station, and once that first element arrived back in 1998, especially once the crew started living on board since 2000. A steady supply of experiments and also crew supplies has been important. So Dragon is joining a family and a fleet of cargo vehicles that service the station. The Russians have, of course, their Soyuz vehicle, which takes the crews up to the station.
Minicam set up in the cupola via the Node 3 ICP, so you're welcome to come.
They also have Progress vehicles, which take up cargo as well. Those Progress vehicles service the station several times a year. They take up about 2.5 tons of supplies. The Europeans have their automated transfer vehicles, which are bigger. But they only fly about one time per year, and then they dock with the Russian segment. And then the Japanese have the HTV, which is their version of a very large cargo carrier that berths with the U.S. segment. The Space Shuttle was the United States vehicle. Of course, it took up quite a bit of cargo and also returned it back home, and that is one of the capabilities that we lost whenever the Space Shuttle retired. SpaceX now becomes the only vehicle that can return sizable amounts of cargo back to Earth. It is designed to splash down in the Pacific Ocean. And it is actually going to be returning more cargo on this mission than it is taking up. The total mass going up to the station on this flight is 882 pounds of cargo. And then whenever it splashes down, which you see a photo of the May splashdown there, it is going to have 1,673 pounds of cargo inside. There's a live view of Sunny Williams inside the cupola. She and Aki Hoshide getting ready to take a look outside those 7 windows there as SpaceX's Dragon spacecraft closes in. That is the robotics workstation that they will be stationed at as they reach out and grab onto this vehicle and bring it on into the station later on. There is a backup robotic workstation that is up and running inside the Destiny laboratory. That is basically a hot backup that they can move to fairly quickly if they needed to, if one of the computers goes down in the cupola. But you'll hear some radio communication between the crew and the team here in Houston as they finish these setup maneuvers over the next hour or so. Capture time today for Dragon still set for 6:22 a.m. Central Time, 7:22 a.m. Eastern Time. A little more than 3 hours from now. But in between now and then, there's a series of burns that Dragon will conduct. And then a series of hold points at which there will be some go, no-goes, and we will update you on the times of those as we get a better idea of this new schedule that we have this morning. These two vehicles are currently flying high above the Earth at an altitude of about 250 miles, or just to the south of Africa right now. We have a couple of more orbits of the Earth before the actual capture will take place, but they are very close to the point at which that will happen above the Earth. So the capture time today at 6:22 a.m. Central Time. These two vehicles should be right about the same point that they are right now, just high above midpoint between the Atlantic Ocean and the Indian Ocean. Right there you see the dot on the screen. That's where the capture should be taking place.
Houston, station on 2 for Dragon approach.
Go ahead, Sonny.
With the AI burn being early, did you want to get into the procedure 1.102 Dragon approach and retreat monitoring early?
All right, Sonny, we're going to call you back for that in about 5 minutes. We're just getting ready to enter the approach ellipsoid.
Copy that.
The Capcom CJ Sturco there talking with Sonny Williams aboard the International Space Station. You will hear this approach ellipsoid mentioned. There's a couple of imaginary circles drawn around the International Space Station. This approach ellipsoid is the first of those. There's a second one that's a bit closer, right around the 250-meter point. That is the keep-out sphere, which again is an imaginary circle drawn around the station, sort of a go-no-go point at which Dragon will hold. And then we'll make sure that all the systems are ready for the approach inside that perimeter around the station. But Sonny Williams, they're continuing to work inside the cupola at the robotics workstation. Also the crew command panel that the crew would use to communicate with Dragon if they need to. Aki Hoshide is going to be taking the lead today, using the arm from that position to grapple onto Dragon. Then later on this morning, they will swap places, and Sonny will be the one that will actually bring it on into the International Space Station. But these two members are part of Expedition 33. The other one is Yuri Malenchenko. This crew has been on board since July together, and they will stay on board until the midpoint of November, at which point they will return to Earth aboard their Soyuz that brought them up to the station back in the summer. This Dragon uses a couple of different systems as it closes in on the International Space Station and performs this automated rendezvous. It uses LiDAR, which is basically a laser version of a radar system that takes a look at the station. There's different reflectors on the station that it picks up. It also uses thermal imagery to analyze the station. Back during the test flight in May, some of the systems on board Dragon were actually locking on to the Kibo laboratory on board the station instead of the Harmony node, which is what it should have been locking on to. But they dealt with that and updated the software, basically told this LiDAR and these thermal imagers to ignore that portion of the field of view, which of course is the whole reason why you have a test flight, is to find out how your systems operate. But everything on board Dragon is working as expected so far. The Dragon and the SpaceX team there in Hawthorne, California are having regular conversations with the team here in Houston. Of course, is talking with the crew on board the International Space Station. There is Aki Hoshide there inside the cupola. It looks like he's got one of the station's onboard cameras taking some HD video of the spacecraft as it closes in. This cupola gives these crews just unparalleled views of both visiting vehicles and also the Earth below. This big bay window in space is pointed straight down at Earth, so they get quite a spectacular view of their surroundings and the spacecraft that fly up toward them. Here inside Mission Control, in addition to the flight director, Ron Spencer, Holly Ridings is also here in the room. Holly is a flight director as well. She was the lead flight director back in May as Dragon performed its test flight up to the International Space Station. She worked with that SpaceX team for months and months on that flight, so she knows the team and the vehicle very well. So she is here to help advise and just kind of watch over today's activities as Dragon closes in on the International Space Station once again. Both of the teams are confirming that Dragon has passed the threshold of the approach ellipsoid. Again, this is one of the imaginary circles drawn around the station. Sort of a milepost, if you can consider it that, where they will continue to take a look at the systems, make sure everything's performing as expected, and it is. The next major milestone will be another mid-course correction burn coming up in about 6 minutes. These mid-course correction burns are designed to do exactly what they sound like, and that is to just take a look at where Dragon currently sits in space relative to both the space station and the other hold points that it needs to arrive at. So they will, in real time, fine-tune these burns and either give more propulsion to them or less, depending on what they need. And that, all in all, will help line up Dragon with the International Space Station, setting up for the capture, which now we are 2 hours and 52 minutes away from, still on schedule for 6:22 this morning.
Station Houston. Dragon range is approximately 1,000 meters. Go to perform step 1 of 1.102. Confirm Dragon is inside and begin monitoring range.
Okay, step 1 of procedure 1.102 is in work.
So Dragon is now within 1,000 meters of the International Space Station. This is the point at which the crew will officially start monitoring the vehicle. They're going to take a look at it and verify everything is what they expect it to be. And we have another mid-course correction burn coming up in about 3 minutes.
Command LED is on. We've got Dragon in sight.
Copy.
This spacecraft is taking up quite a bit of supplies for the crew and just a significant amount of experiment hardware. It's bringing up some supplies for the crew, some food and some clothing, obviously things you need if you're going to be living in space for about 6 months. Crew supplies are about 260 pounds. There's 390 pounds of what we call utilization payloads. These are the experiments. There's some equipment for the fluids and combustion facility hardware. These are the investigations that NASA and its international partners do on how flames and fire behave in space. There's some yeast that is being flown that is part of a what we call the commercial generic bioprocessing apparatus. It's one of the facilities on board. There's some cables for the alpha magnetic spectrometer that are being flown as well. There's some capillary flow experiment hardware that takes a look at how fluids behave in space, obviously a lot different than it does here on Earth. There's some parts of the MISSI experiment, which is the Materials on International Space Station experiment, taking a look at how different types of materials behave in space and how they degrade and react. There's some experiments being flown by the European Space Agency. And there's also what is known as a glacier freezer that is being flown. These used to be flown during the shuttle days. Basically, it's a huge footlocker that experiments can be put in and frozen. Temperatures can be kept as low as negative 301 degrees Fahrenheit. That's negative 160 degrees Celsius. This particular glacier is being flown empty. It's going to be packed full during the 18 days that Dragon is up on board the station. And a lot of these experiment samples and biological samples that have been conducted and gathered on board the station over the last several months are going to be returned to Earth. The team's now confirming that this mid-course correction burn has been conducted. Everything checked out according to plan. Sunny now grabbing one of the big cameras on board, taking some photos of this vehicle that is heading toward them. They've got a series of cameras on board with 400mm lenses and 800mm lenses. These are the cameras that used to be used to photograph the space shuttle during the rendezvous pitch maneuver, but they can zoom in extremely close and get some very high fidelity photos of these vehicles. But again, Dragon's within 1,000 meters of the station, so the crew should be getting a good view of this vehicle at this point in time. The Attitude, Determination, and Control Officer here in Mission Control is also confirming that the station itself is now being steered around to the proper position for capture. It takes about 5 minutes to move this entire million-pound orbiting complex around. These two vehicles are over the Indian Ocean now, heading up toward the northeast. This is Mission Control Houston. Our view of Dragon becoming even clearer as the spacecraft closes in on the orbiting complex. These two vehicles heading up over parts of Indonesia here in just a few minutes, continuing on up over the Pacific Ocean. They're going to be heading into nighttime in about 20 minutes. This is a live look at Dragon's view of the orbiting complex now. Again, this vehicle uses a series of instruments on board. During these final minutes of navigation, there's a LiDAR system that paints a laser on different targets of the International Space Station. There's a thermal imager. And it also uses what's known as relative GPS, just like what you would use here on Earth on your phone or some sort of GPS system. Dragon picks up not only GPS satellites, but it also uses what's called relative GPS, which it takes a look at the station itself and then compares those things to find out exactly where it is. Right now, the vehicle is using its LiDAR system to paint the space station and to continue to fine-tune its course toward the orbiting complex. But you can clearly see the U.S. section there at the top with the Columbus Laboratory there on the left, the Kibo Laboratory there on the right. And the station's giant solar arrays there extended out. The team here in Mission Control has confirmed that the space station has reached the proper position for capture. So they have steered around this entire orbiting complex, getting ready to set up for this morning's arrival of Dragon. Again, we're on schedule for 6:22 a.m. Central Time. As Dragon gets closer, you can see the makeup of the spacecraft, the trunk there in the middle, where the solar arrays are attached to, is 9.2 feet tall and 12 feet wide. The Dragon itself there at the top is 14.4 feet tall and 12 feet in diameter. That is the part that comes back at the end of the mission for the splashdown. If you look very closely, you can see the strobe light that is turned on there on the nose of Dragon. But the solar panels are 54 feet wide, which is about a 5-story building laid over on its side. So this vehicle is fairly sizable. Sonny Williams continuing to take pictures as the daylight begins to fade a bit. The space station and Dragon heading off into night above the Pacific Ocean here in the next 14 minutes or so.
Station on Houston on Space to Ground 2, when you have a second, we'd like somebody to turn the lab camera on, please.
Okay, in work.
Thanks, Sonny. We'll be able to see the lab RWS overlays then.
Copy that.
CJ Sturco there talking with Sonny Williams aboard the International Space Station. They're going to turn on one of the cameras inside the Destiny laboratory. What this will do will allow the ground teams to get an over-the-shoulder view of what the crew is seeing on the robotics workstation. If you saw the flight back in May, or you've seen the Japanese HTV arrive at the station, you know which view we're talking about. Basically, it's a camera view from outside the station looking down at the vehicle as it nears the station, and there's sort of a green box that gets automatically drawn around the spacecraft, letting the crew know whether the vehicle is staying within its bounds or not. They will just monitor that in real time here in Houston, and of course if we get it, we'll put it out here on NASA TV. The team confirming that Dragon should be arriving at the 350-meter point here in just a few minutes. At this point, Dragon has finished basically moving laterally. It's going to move in a straight line up toward the station now, up to this 350-meter hold point. This is one of the hold points we talked about, but also what will happen, and you'll see it here. Once Dragon gets there, it will spin around 180 degrees. It does this to properly align itself for the remainder of the trip up to the orbiting complex.
Houston Station on 2 for the lab camera. Let me know if you need any adjustments.
Aki, we're not seeing it just yet. Give us a second to try and come on board.
Okay, copy that.
This is a live look at that robotics workstation view we talked about. This is what the crew will be taking a look at. You can see all the different data that they have access to, telling them exactly where the vehicle is as it closes in on the station. As Dragon gets closer, you'll see a green box drawn around it. That's just how they monitor the position of the spacecraft to make sure that it is staying within bounds. Again, we're just a few minutes away from the arrival to the 350-meter hold point.
That lab camera for a live MPC. We're just getting it standard def right now. We want to see you in high def.
Okay, copy that.
According to the pre-flight timeline, Dragon was going to arrive at this 350-meter hold point at 4:09 a.m. Central Time. All of the burns today in these maneuvers have been running between 10 and 15 minutes ahead of time. That's just because these timelines are tweaked in real time once the flight gets underway. We are still expecting the capture to take place around 6:22 a.m. Central Time. Of course, we'll update you if that time changes, but there's a loss of signal with the International Space Station as the communication link will reset itself just a few minutes before that 6:22, so they're wanting to kind of hold to that point in time. But we'll see how the morning progresses.
And Houston Station on 2, the lab camera is connected to the NPC.
Checking. And Aki, we're getting good high-def video now from the lab RWS.
Copy that, thanks.
This is Mission Control Houston. The SpaceX team has confirmed that Dragon has arrived at the 350-meter hold point away from the International Space Station. In about a minute and a half, Dragon will spin itself around 180 degrees. So Dragon is now steering itself around 180 degrees. This won't take very long to accomplish this. Once this is finished, should depart this 350-meter hold point and head up to 250 meters. This is Mission Control Houston. Again, this is a view from Dragon, taking a look up at the International Space Station. You can tell that the Dragon itself has turned around 180 degrees. The U.S. section now there on the bottom. If you look closely there at the sort of that upside down T, you can see the Kibo laboratory with its front porch there. That is the exposed pallet. There on the far right-hand side is the Columbus laboratory. The station's solar arrays are basically at this point turned on end toward Dragon. So you can see the radiators there extended out. The Russian section there toward the top of the screen. But the spacecraft should be arriving at the 250-meter hold point in 3 minutes and 45 seconds. Dragon is passing 270 meters at this point in time. Its range is closing in fairly slowly. It's about 0.2 of a meter per second toward the International Space Station, but of course that is by design. These two vehicles are getting ready to make a nighttime pass over the United States. They'll be moving from the northwest down to the southeast, including the states of Oregon and Washington, parts of Colorado, and New Mexico, and over the great state of Texas, of course, our home, and then over the Gulf of Mexico. There are opportunities in the U.S. to spot both Dragon and the International Space Station this week. Most of these opportunities are in the evening. It has to be timed just right when the sunrise still is hitting the two spacecraft, but has gone down below the horizon. So it's usually in the early evening or early morning hours. And this week it's going to be in the evening, so we invite you to check it out. Just log on to spaceflight.nasa.gov. Once again, spaceflight.nasa.gov. And find your hometown by selecting real-time data and then sighting opportunities, and then just drill down from your state to your hometown to find out what the times are when you can spot it. Dragon has arrived at the 250-meter arrival hold point. It will stay here, and we'll have a go, no-go coming up here shortly.
247.4. Verify the gray crew aboard corridor is displayed on the overlay. The CCP LED says hold.
Okay, Sonny, we copy and concur.
station, do you want a Black Bravo?
We'll take the Black Bravo, Sonny.
Okay, and just with the caveat, it's sort of hard to see the vehicle. It's small in the screen right now. So the white strobe is within the crew abort corridor. The vehicle size, like I said, it's a little bit hard to see in the monitors right now. So it looks like it's on right now. The white strobe position with respect to the strobe tracker is probably about one vehicle as best I can see it aft and slightly to starboard. And the strobe tracker position with respect to the crew abort corridor center is right on. And that is essentially both in camera 07 and 09 monitors 1 and 3.
All right, that's a great report, Sonny. Thanks a lot. Station Houston, MCC Hawthorne and MCC Houston are ready for Dragon approach from 250 meters. Perform step 3 in 1.102.
Okay, step 3 and work.
So a big milestone for this morning's activities as the SpaceX Dragon spacecraft continues to close in on the International Space Station. Both the SpaceX team and the team here in Houston have done their final go-no-go poll for Dragon to enter into what's called the keep-out sphere. This is an imaginary circle drawn around the station that any visiting vehicles must stay out of. But all systems on board Dragon have checked out as expected. All of the sensors are working as they expect them to. They're getting ready for the crew to issue a command to Dragon for it to resume inside this sphere around the International Space Station. And the team's now confirmed that Dragon has resumed its approach.
Complete. Resume has been executed. See approach mode.
All right, we see that down here as well, Sonny. Great news.
Dragon will move from 250 meters up to 30 meters away from the station. It will hold there once again. There will be another go, no-go at that point.
The intermediate report, primary and secondary ranges are decreasing, and I'll get you a Black Bravo in just a minute.
All right, stand by.
It's nice to see Dragon flying over the U.S.
Hey, Sonny, we're just ready to call you. We got good KU down here right now, so we do not require a Block Bravo, and we will call you back when we lose KU and need the Block Bravo, but we got a good solid band right now.
Okay, sounds great.
Dragon is now closing in at a rate of about 0.07 meters per second. Nice and slow and easy as it closes in on the International Space Station. Its distance right now, 245 meters away. The crew is steadily watching at the robotics workstation, although right now they're in the dark as they fly over North America. So Dragon just appears to be a blinking strobe light at this point in time, but when the sun comes back up here shortly, the crew will get a fairly dramatic view of this vehicle as it gets even closer to them, and they get ready to reach out and grapple it. We're still on schedule this morning at 6:22 a.m. Central Time. As we've talked about, these burns that Dragon has been conducting and these hold points have been happening about 10 to 15 minutes earlier than anticipated, which of course is good news. Everything running fairly smooth this morning, but the capture time is still going to be set for 6:22, even though we're a little bit ahead of schedule. The reason for that is because there's actually a loss of communication with the space station in the minutes before the capture time, and of course they want to make sure that they've got a good communication link up with the crew in case the crew has any questions or needs anything whenever that capture takes place. As we take a look at this overlay, this is exactly what the crew is seeing on board. There's a lot of numbers and data there, but if you're following along, if you look on the right-hand side, that's a last set of numbers there toward the bottom where you see range and rate. You see primary and secondary. Those are the two data streams coming in to the crew. You see it says 238.74. That is the distance in meters from Dragon to the station. And then the range and rate on the far right-hand side, that is the closure rate. So if you want to follow along with us, that is what those numbers mean. This view from Dragon of the space station becoming even clearer. You get a sense of just how big this orbiting complex truly is from tip to tip there, from left to right. It's about 357 feet. which amounts to a 36-story building laid on its side. It's just enormous there up in space. Of course, it's going to look quite a bit bigger as Dragon continues to close in. Right now it's at about 230 meters away from the orbiting complex. It is heading up to a position at 30 meters, roughly 90 feet away from the station. It will hold there once again. There'll be another go, no-go poll done by both the SpaceX team and the NASA team. And then the next major step will be for Dragon to move from 30 meters up to 10 meters, and that's the capture point. The SpaceX team there following along as their vehicle continues to close in on the space station. They are constantly comparing the data that the Dragon sees from its LiDAR sensors and also its thermal imagers, as well as its GPS systems on board. But you can clearly make out the Russian section there at the top, the U.S. section down there at the bottom. The massive solar arrays, which are turned on their end toward Dragon. Right now, this is a technique known as feathering. It's done anytime a vehicle comes up or departs from the station. These solar arrays are big, but they're fairly delicate in terms of what they're made out of. So they don't want any inadvertent pluming taking place from any of the jets on board the spacecraft that come up toward the station, so they're turned on edge. Much like what you would do if you stuck your hand out a car window and you would stick it into the wind rather than against it. Same sort of principle in effect there. The SpaceX team is confirming that Dragon right now is 205 meters away from the station. Its rate is 0.8 of a meter. So fairly slow. But of course, they do this very methodically during these final moments of these vehicles nearing each other.
Station Houston on Space to Ground 2. Dragon is inside the 200 meters, so crew now has authority to issue abort in case of corridor violation during LOS.
Houston station copies, and we see the crew abort corridor is now green.
The crew having to wear some sunglasses there as the sun has come up. They're taking every opportunity they can to capture video and still photography of Dragon as it gets closer. Right now it is 185 meters away from the station. Its rate is 0.07 meters per second. If you look closely, you can see the pulsing of the jets of Dragon as it maintains its position. And this is a view looking straight down the robotic arm at Dragon. As we mentioned, Aki Hoshide is going to be in charge of using that arm to reach out and snag Dragon out of the sky once it arrives at the capture point later on this morning. Right now, according to the clocks here in Mission Control, Dragon will arrive at the 30-meter hold point in about 35 minutes. Capture is still on track for 1 hour, 47 minutes from now, or 6:22. These two vehicles are over Bolivia right now, heading down toward the southeast. These views always are a bit deceptive. These vehicles look like they are flying very slow and gracefully through space as they fly together. In reality, they're going extremely fast, 17,500 miles an hour, which is basically Mach 25. And the crew is continuing to take a look at this robotic workstation view, which we see here. That's a big green box is what Dragon needs to stay within. They have a crew command panel there at their fingertips that they could use to either issue a retreat or abort command if they had to. But everything going according to plan. Dragon right now 163 meters away from the station. The rate's still the same as it was before, basically 0.06, 0.07 meters per second. Yeah, Dragon is now 145 meters away from the station, continuing to ease on toward the orbiting complex. The next major stopping point will be at the 30-meter point. It'll take about 27 minutes to get up there. So we will stand by and watch as this vehicle closes the distance between itself and its destination. And then the activity will pick up quite a bit as it moves from the 30-meter hold point up to the 10-meter capture point. And that is where Sonny Williams and Aki Hoshide, with Aki at the controls of the station's robotic arm. From there, inside the cupola, we'll steer that arm out and grab Dragon out of the sky. Our capture time still scheduled for 6:22 a.m. Central Time, 7:22 a.m. Eastern. This is Mission Control Houston. Dragon's now at 119 meters away from the station. Still moving up toward this 30-meter arrival point. This green box that you see drawn on the screen there, that is the approach corridor that Dragon must stay within. It is three-dimensional. Almost looks like a pyramid that points up toward the International Space Station, with the base being down toward the vehicle itself. So as Dragon gets closer, that box will taper in and become smaller, much like a pyramid would, if you can imagine that. And that's just because the area in which Dragon can move around and needs to hold itself obviously gets narrower as it gets closer to the complex itself. Once Dragon arrives at this 30-meter hold point, it'll spend about 14 or 15 minutes there, and then it will depart and move up toward the capture point, which is 10 meters. Everything so far has been running about 10 minutes, sometimes 15 minutes ahead of schedule. All the different maneuvers that Dragon needed to accomplish, it did. All these arrivals at these hold points have been ahead of schedule as well. Once we get a better sense of if they're going to go for capture a little bit early, we will pass that on to you. There's a communication gap in the 6 a.m. Central Time hour that they'll probably most likely want to avoid trying to capture Dragon during that point in time, but they could go before that, or they could stay with the planned time of 6:22. So we'll see how the remainder of this goes this morning. We'll update you once we know something, but as of right now, 1 hour, 30 minutes from now, that is when Dragon will be captured. The SpaceX team continuing to watch their vehicle as it closes in on the International Space Station. Dragon performing fairly flawlessly this time around. All of the navigation systems are working as expected, as we talked about back during May. Some of the systems on board Dragon locked on to different portions of the space station than what they were designed to. They were actually seeing the Kibo laboratory. It's one of the biggest parts of the station, but it was picking up reflections from that and locking onto that. Of course, Dragon's not meant to dock with Kibo, so they basically reprogrammed some of the software on board for this flight to really ignore the field of view where Kibo resides, and everything is working straight down the line this morning. Right now the vehicle is 92 meters away from the station, closing in at 0.07 meters per second. There's a view from the crew, what they're seeing on board. That green box is what Dragon needs to stay within. But both Aki Hoshide and Sonny Williams are down in the cupola, getting quite the view of this spacecraft as it heads up toward them for this morning's rendezvous.
Houston Station on 2, we see us at 75 meters. See we're about to lose KU. I'll give you a black Bravo at your
Okay, we don't need to block Bravo just yet, Sonny. We'll probably call you back in a few minutes to get another one. We're just got a good picture right now as we lose the KU. And Sonny, block Bravo not required.
After that.